Today we discuss regarding the optical fibers. We start with introduction, then we go to the evolution of optical fiber, construction of optical fiber, working principle of optical fiber, classification of optical fiber, attenuation, advantages and disadvantages of optical fiber, and finally applications of optical fiber. Optical fibers are light guides used in optical communication as waveguides. They are transparent dielectrics and able to guide visible and infrared light over long distances. Its working is based on principle of total internal reflection. It permits transmission of waves over longer distances and at bandwidths than other forms of communication. In 1870, John Tyndall, a British physicist, demonstrated to Royal Society that light can be guided along a curved stream of water, employing well-known optical phenomena, total internal reflection. First glass fibers were made in the 1920s, but concept of cladding brought in forth in 1950s. Later, around 1954, Brian Hopkins and Narinder Singh Kapani achieved low loss transmission through 75 cm bundle of 1000 fibers. In 1960, Theodore Maiman invented first laser, that is the ruby laser, where he used ruby crystal as the active media, which created a sensation in optical fiber communication because of its high coherence property. Nishizawa was the first to propose the use of optical fibers for communications in 1963. Charles Caillot and Hockman were first to reduce attenuation in optical fibers below 20 decibels per kilometer, making it a practical communication medium, which earned Caillot the Nobel Prize in Physics in 2009. Optical fiber construction. Core is made up of glass or plastic with a higher refractive index of refraction than cladding. Carries the signal. Core mainly carries the light signal from one point to other point. The cladding is made up of glass or plastic with a lower index of refraction than the core. That means refractive index of cladding should be lower than that of the core. Buffer or coating that is used, it protects the fiber from mechanical damage, chemical reactions and moisture. How it works. Now a ray of light is incident on interface of two media, that is air and glass. Then if you draw a normal to the incident ray, then angle of incidence you can say theta I. Now ray is refracted to the interface next media with an angle, refraction angle, that is theta R. Now when a ray of light travels from a denser to a rarer medium such that the angle of incidence is greater than the critical angle, the ray reflects back into the same medium. This phenomenon is called total internal reflection. In the optical fiber, the ray undergoes repeated number of reflections unique until it emerges out of the other end of the optical fiber, as we show in the figure. Now what is the acceptance angle? It is the maximum angle at which external light rays may strike the interface of air or any media and core and satisfies total interreflection condition at core and cladding interfaces. Then what is the numerical aperture? It is the light gathering capability of fiber, mathematically expressed as the sign of acceptance angle. That I can say numerical aperture equal to sign of acceptance angle. Then D number of modes supported by an optical fiber is obtained by cutoff condition known as normalized frequency or V number, and it gives V equal to 2 pi A by lambda into numerical aperture. Then based on this we can write number of nodes optical fiber can support n equal to 1 by 2 into V square. Then we can discuss regarding the classification of optical fibers. Optical fibers are classified into three categories based on the number of modes they can support. That is, I can say two types, single mode and multi-mode, and based on the refractive index profile, that is step index and graded index. Now, what is a single mode step index fibers? Only one mode can propagate through the fiber. That means single mode. This type of fiber has small core diameter around 10 micrometer and high cladding diameter, that is 125 micrometer, and the difference between the refractive index of core and cladding is very small. The light is passed through the single mode fiber by laser diode. So this is where we use the lasers in the optical fibers. Then multi-mode step index fiber. Multi-mode fiber allows a large number of modes for the light ray traveling through it. The core diameter is 200 micrometer and that of cladding is 380 micrometer. The relative refractive index difference is also larger than single mode fiber, and they are not suitable for long distance communication due to large dispersion and attenuation of the signal. Next comes multi-mode graded index fiber. The graded index fiber, in the graded index fiber, the refractive index in the core decreases continuously when you go radically outwards from the axis. This causes the light rays to bend smoothly as they approach the cladding rather than reflecting abruptly from the core cladding model. The attenuation. It is the loss of signal strength or power supported by the optical signal as it propagates through the fiber. It is also called fiber loss. Attenuation is caused by mainly absorption, scattering, and radiation. In the absorption by impurities. Now we know that in making the process of the glasses, some transition metals get into the material, and these materials are transition metals like iron, cobalt, chromium, nickel, and they will absorb the light energy and they will be excited to the next available level, and while coming back de-excitation they emit the light maybe in different wavelength or some type of different direction. Because of this the light is lost or our signal is lost, and even because of the OH ion hydroxy. Now second is the intrinsic absorption. This is the basic absorption because we are making core by glass material or plastic material. Since it is a material, it can absorb energy, and because of this absorption there might be loss, and we cannot overcome this loss since we are using the media. Now second is the scattering, that is the Rayleigh scattering, and second is the other scattering, like any imperfections in the core material that can happen. Finally, radiation losses. One is the macroscopic bending loss, second is the microscopic bending losses. Now what are the advantages? So since we know that core or cladding are made by silica oxide and plastic, these are very abundantly available materials, then these OFCs can support wide bandwidth, lightweight and small size, immune to electromagnetic interference, low cost, that is cost per meter per channel, no energy radiation, information safety, superior attenuation because you can send it to long distance, compatibility with solid state sources, lack of sparking. Now disadvantages of optical fibers. So it is very difficult to join. Highly skilled staff will be required for maintenance. Precision and costly instruments are required. Tapping per efficiency is difficult, costly for underutilized. Fiber undergo expansion and contraction with temperature. It disturbs the critical alignments. Now applications used in optical fiber communication for transmission of analog and digital data, used in cable TV, used in imaging, optics and spectroscopy, used in illumination applications, fiber optic sensors and couplers, industrial applications, medical applications and military applications, many more. Then for optical fiber communication system, here we use the information source, electrical transmitter, optical source, optical fiber cable, optical detector, electrical receiver and destination point. Thank you.